Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look. Here it is, our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron. 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is the brand new RTX Blackwell 5090. Now, even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? It's literally this big. The voltage regulator design is state-of-the-art, incredible design. The engineering team did a great job. So here it is. Thank you. Well, now with the Blackwell family, RTX 5070, 4090 performance at 549. Impossible without artificial intelligence. Impossible without the 4 TOPS, 4 teraops of AI tensor cores. Impossible without the G7 memories. Okay, so 5070, 4090 performance, $549, starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Starting, of course, we're producing at very large scale availability starting January. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1299, this 5070 laptop has a 4090 performance. I think there's one here somewhere. Let me show you this. This is look at this thing. Here. There's only so many pockets. Ladies and gentlemen, Janine Paul. So can you imagine you get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate, using artificial intelligence, all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing is, oh, here we go. Thank you. This is a surprisingly kinetic keynote. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Okay? So, ladies and gentlemen, the RTX Blackwell family. But what we basically have here is 72 Blackwell GPUs, or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room's supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips, okay? And we have 130 trillion transistors in total, 2,592 CPU cores, whole bunch of networking. And so these, I wish I could do this. I don't think I will. So these are the Blackwells. These are our ConnectX networking chips. These are the NVLink, and we're trying to pretend about the NVLink spine, but that's not possible, okay? And these are all of the HBM memories, 14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle of the Blackwell system. The Blackwell dies right here. It is the largest single chip the world's ever made. But yet, the miracle is really, in addition to that, this is the Grace Blackwell system. Well, one of the most important things that's happening in the world of enterprise is Agentic AI. Agentic AI, basically, is a perfect example of test time scaling. AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools. It might be using a calculator. And it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing, is going to go through the roof. It's going to go through the roof because we want better and better answers. Well, to help the industry build Agentic AI, our go-to-market is not direct to enterprise customers. Our go-to-market is we work with software developers in the IT ecosystem to integrate our technology to make possible new capabilities, just like we did with CUDA libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are doing computer graphics or doing linear algebra or doing fluid dynamics, in the future, on top of those acceleration libraries, CUDA acceleration libraries, we'll have AI libraries. We've created 3 things for helping the ecosystem build Agentic AI. NVIDIA NIMs, which are essentially AI microservices all packaged up. It takes all of this really complicated CUDA software, CUDA DNN, Cutlass, or TensorRT-LM, or Triton, or all of these different really complicated software, and the model itself, we package it up, we optimize it, we put it into a container, and you could take it wherever you like. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI. And these AI models run in every single cloud, because NVIDIA'S GPUs are now available in every single cloud. It's available in every single OEM. So you could literally take these models, integrate it into your software packages, create AI agents that run on Cadence, or there might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf. And so the way that you would bring these specialized agents these special agents into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI agents be trained for the type of language in your company. Maybe the vocabulary is unique to your company. The business process is different. The way you work is different. So you would give them examples of what the work product should look like. And they would try to generate it, and you would give it feedback. And then you would evaluate them, so on and so forth. And so and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say. And we even give them access to certain information. Okay, so that entire pipeline, digital employee pipeline, is called NeMo. In a lot of ways, the IT department of every company is going to be the HR department of AI agents in the future. Today, they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve a whole bunch of digital agents and provision them to the companies to use. Okay, and so your IT department is going to become kind of like AI agent HR. And on top of that, we provide a whole bunch of blueprints that our ecosystem could take advantage of. All of this is completely open source, and so you could take it and modify the blueprints. We have blueprints for all kinds of different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the NVIDIA Llama Nemotron language foundation models. Llama 3.1 is a complete phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not, basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. Very large, very capable. And so all of this is now available online. Well, these models are incredible. It's number one in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. And so this is the NVIDIA Cosmos. The platform has an autoregressive model for real-time applications. has diffusion model for a very high quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end to end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open and available on GitHub. We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open, we really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse, and the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principled physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting. And of course, for robotics, for industrial applications, it is very, very clear. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers, the training systems to train the AIs, the simulation systems, and the synthetic data generation systems, Omniverse and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use one or two or three of the computers. We're working with just about every major car company around the world. Waymo and Zoox and Tesla, of course, in their data center, BYD, the largest EV company in the world, JLR's got a really cool car coming, Mercedes has a fleet of cars coming with NVIDIA starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and NVIDIA are going to partner together to create their next generation AVs. Just so many cool companies, Lucid and Rivian and Xiaomi and of course Volvo, just so many different companies. Wabi is building self-driving trucks. Aurora, we announced this week also that Aurora is going to use NVIDIA to build self-driving trucks. Autonomous, 100 million cars built each year, a billion vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or, fully autonomous coming up. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. This business for us, notice in just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year probably on a run rate about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car is called Thor. I have one right here. Hang on a second. Okay, this is Thor. This is Thor. This is a robotics computer. This is a robotics computer. It takes sensors, just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, LiDARs, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a humanoid robot, it could be the brain, it could be the manipulator. This processor basically is a universal robotics computer. Humanoid robots, my friends, the ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. This is NVIDIA'S latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA's software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside. It's just so cute. And this is the chip that's inside. It is in production. This top secret chip we did in collaboration. The CPU, the Gray CPU, is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible what we could do. And it's just, I think I was trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. Who doesn't want one of those? And if you use PC, Mac, anything, because it's a cloud platform. It's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like. If you would like to have double digits, This is what it looks like, you know? And you connect it together with ConnectX, and it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits. Okay. Well, let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI foundational world foundation model, the world's first physical AI foundation model. It's open, available to activate the world's industries of robotics and such. And three robots. We're working on Agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. Have a great CES, everybody!